kids, more review. Let's see. Today we're going to talk about forces, exponential equations, systems of equations we're going to solve algebraically and graphically. I'm telling you, it sounds like a lot of fun. I'm excited to be here. Are you? I got a new table. It's kind of bouncy. We'll see how that works. At any rate, let's see. A couple things. A little housekeeping. One, if you want the document that I'm doing this video on, go to www.mrkrausemath.com. Kraus is spelled Krause. And click on Regents Review. And near the bottom of the page, this is day 6 of After School Review. So day 6, when you click down there, you'll see all my other days, including the documents that you can download to print, so you can try these problems out on your own, as well as a link to the video. Hopefully this helps. Like I said, if you enjoy watching the videos, please hit the subscribe button. I'm still looking to get a few more subscribers. I know there's a lot of you watching my videos without hitting the subscribe button. It's kind of irritating me. And my students are tired of hearing me say, I wish my kids would more people would subscribe. But it doesn't matter. Hopefully you do well. Regents exam is in 1 week from, well, this Friday, which is in a couple days from now. So you got about 9 days before that exam. Hopefully things are going well for you. Let me know if you have any issues or any questions. Hopefully everything on my computer is going to work. It just updated and was causing me all kinds of grief a few minutes ago. So let's hope it works. All right, kids, let's get started. Anytime you see this word right here, and I'm going to highlight. By the way, I'm suffering from a cold. I'm just getting over a cold, so I'm going to cough like crazy. I wish I could mute it, but I can't. So, time you see this word forces, the first thing you're going to do is draw a parallelogram. There's one force, but you're going to try to draw the very best parallelogram that you can draw, even though that line's terrible. And label them 12 pounds and 20 pounds. Act on a baddie at an angle of 60 degrees. So the 60-degree angle is between them. Okay, the question says, find to the nearest pound the magnitude of the resultant. Now, the resultant is the, if you were pushing on a body going this way, and I was pushing on a body going this way, eventually that body would kind of go in this direction. So you should already know this. Your teacher should have already taught you this. This thing right here, this green line, is called the resultant. We're looking for that. That's what we're going to call X. We got a little bit of work to do. If this is 12, then this is 12, because I'm going to work in this triangle down here. Well, if I'm going to work in this triangle down here, I need this angle as well. And that's the trick to kind of doing these problems, is you have to know what this angle is right here. Well, this angle and this angle are supplementary, which means they add up to 180 degrees. So if this is 60, then this is 120. Okay, so I want to find X. So what do I have? I have side, angle, side. And there are 2 times that we use the law of cosines. The law of cosines is used for side, angle, side, and side, side, side. Sorry, I went with side, side, side first. Those are the 2 times we're really going to want to use the law of cosines. All right, well, in this case, I just want to use the law of cosines. I want to find X. So if you look over at your law of cosines, which is right here again, I've got it all highlighted from my last videos I've been doing. But the law of cosines is very simple. The big thing is whatever you're looking for, either an angle or a side, must go at the beginning or the end. Excuse me. So when I do this problem, I'm looking for X. I'm going to call this big X over here. So X starts it. So it's X squared is equal to. Then we're going to just use the other 2 sizes like the B and C. Equals 12 squared plus 20 squared minus, that's a squared, 2 times 12 times 20 times cosine of 120. Now, don't get all wrapped up. Be careful. You have to hit cosine on your calculator. So don't try to do this thing piecemeal. Don't try to figure out what this is and then try to figure out what this is and then try to figure out. Just type the whole thing in at one time, all in your calculator. You'll make less mistakes. Less mistakes is always better. So it was 12 squared plus 20 squared minus 2. Oftentimes kids forget that 2. 2 times 12 times 20 times, make sure you hit cosine of 120. And I get 784. Well, that's easy. So x squared is equal to 784. Well, to find x, it should be obvious that you're going to take the square root of both sides. So you need to take the square root of this. So second square root, control answer. And square root of 784 is, in fact, 28. So in this case, the resultant is 28. Done. If two forces of 30 pounds, forces, I heard the word forces, draw my parallelogram. By the way, this is very difficult to draw shapes using this. I don't know why, because I don't have a piece of paper to follow along, and I'm trying to draw in the air, and it's kind of difficult. So two forces of 30 pounds and 40 pounds. Always make one side longer. Act on a body with an angle of 120 degrees. So what? I'm going to make this 120, which makes this 60. And I'm sure the resultant's coming in. Find to the nearest pound the magnitude of the resultant. Simple, simple, simple. Same exact problem. Same exact problem. We got side, angle, side. That screams. Ah! No, I'm just kidding. I scared you. Sorry. We're going to use the law of cosines. So it basically is the exact same problem we just did. X squared is equal to 30 squared plus 40 squared minus 2 times 30 times 40. Yes, these problems are going to get more difficult. If you'd like to fast forward and get past the easy ones, you're not going to hurt my feelings. I'm okay with that. I really am. Just because I put all this time and effort into this video and you're not watching it. All right, so we're going to type this in. So 30 squared plus 40 squared minus 2 times 30 times 40. Don't forget, lots of kids forget that too. Times the cosine of, was it 60, I think? 1,300. Was it cosine 60? Yeah, it was. So 1,300. Make sure your answer makes sense. Like 1,300 wouldn't make any sense, right? Oh, yeah, I got to take the square root of that. So the square root of 1,300 is 36.0555. 36.0555. Find the nearest pound. Well, that's easy. X equals 36. Catching 2 out of 20. This is going to be a kind of a mix of problems to do today, kids. All right. Two forces act on a body such that the resultant is 50 pounds. Oh, wait a second. Now we're going to do something a little bit different. Oh, gosh, guys. I'm really sorry about all that coughing. It's like the more I talk, the more I cough. The more I do math, the more I talk. So ergo, if you took geometry last year, the more I do math, the more I cough. Gosh. So, two forces. This is our force 1 over here, and I got force 2 over here. Now be careful. Act on a body, it always sounds weird, such that the resultant is 50 pounds. So this is my resultant right here. This long line from here to here is 50 pounds. Now, be careful with the way this is worded. It's kind of worded kind of tricky. Got to be careful. It says, let me highlight this, and hopefully you guys have a highlighter for your test. It says the measure of the angles between the resultant and the forces are 25 and 38. So what I want to do, I'll do this in blue, is one of these is 25 and one of these is 38. Now, if I combine those two, 25 plus 38, what's that, 63? I think it's 63. So that's 63 degrees. So that means that this angle here is 117. And if you actually do the math, you'll find out that this angle here is 38 degrees. Or you can remember alternate interior angles from geometry. But every time I say the word geometry, everybody goes, proofs. No more proofs. I don't want to do proofs. I got it. We're not doing proofs. All right. What do we got to find? Okay, it says find the magnitude of the larger force. Now, You got to be careful the way you word this, or the way you do this. Notice this angle's smaller. This angle up here is larger. And wouldn't it make sense that the larger the angle, the larger the force opposite it? And by the way, you notice how I put X and X? This should be probably a Y. So we want to find X. All right. What in the world do I have? By the way, I put 50 degrees here. I'm not sure why I put that there. That should be 50 pounds. So let's see what I have. I have all three angles and a side. And remember what I said before. We're going to use law of sines if we have side, 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 or side, angle, side. The key is you need two sides. I do not have two sides. What I have is angle, angle, side. I have angle, angle, side. And that is the law of sines. So what we're going to do is we're going to put the 50 over the sine of 117, and we're going to set that equal to the x that we want over the sine of 38. Now, we're going to do what every kid loves to do, and that's cross multiply. Multiply these two together, I get 50 times the sine of 38 is equal to these two multiplied, x times the sine of 117. To get x by itself, we divide by sine of 117. Divide by sine of 117. See ya, wouldn't want to be ya. You are making me mad. Okay, so this stuff right here, we're going to type into our calculator. So, control division. I have no idea what it was. Oops, wrong person. 50 sine 38 times the sine of 38 all over the sine of, don't remember. This is the problem with getting old. Yes, I know I'm bald, but I'm only 46, and I'm getting old because I can't remember things. All right, type that in. We get 32.18699. X equals 32.18699. Come back. Don't tell me this is your answer. Come back. It says find the nearest pound. Nearest pound. So my answer is 32 pounds. Do you have to put units? You do not. You do not, because the question says how many pounds. If you answer with 32, you are correct. Is anybody else having fun? I'm having fun. I'm sick. It's late at night. 7:50. I told you I was old, right? It's like late. You know, I'm like that guy, that grandpa that goes to bed early. Yeah, that's me. Oh, yeah, that's me. All right, you ready? Two forces. Boom. See the word forces. Draw my parallelogram. You guys are going to be like freaking amazing parallelogram drawers by the time you're done with this, if you watch the whole thing and you don't skip ahead and make mine feel bad. When two forces of 12 pounds and 8 pounds, so make 12 and 8, make sure they make sense, act on a body, the magnitude of the resultant is 15 pounds. Oh, we're going to get the resultant. 15 pounds. Now let me keep going through this. This is 8. And don't know anything else. Find to the nearest degree, highlighting these things, nearest degree right there, bam, nearest degree. Wait, I want to highlight degree, to the nearest degree. The angle between the resultant and the larger force. So I want the angle between the resultant, which is this 15, and the larger force. Well, here's the larger force. So I want this angle. We're going to call this X. Oh yeah, I have side, side, side. See, I made you think for a second. You thought I didn't know what I was talking about, but I do. We have side, side, side. And anytime I want to find an angle and I have side, 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 we're going to use the law of cosines. All right, so we'll call that X, which means that this side is side X. Okay, if you like A, B, C, and D, I don't really care. I call them X. So we're going to put X, little x squared here, is equal to, and I'll call this Y, and I call this Z just for fun. But you don't like that? Okay, let's use the formula then. Let's use you know. Someone said to me they don't like that, so I'm upset. I don't want to do it. So we're gonna call this. Oh God! Wait, Control Z. Let's see if I can just get that X. It's impossible. So let me put this back in. So we'll call this A, angle A. So this is little a. We'll call this B. So this is capital B. And we'll call this little c. And this is capital B. Okay. So the formula is A squared equals B squared plus C squared minus 2BC cosine A. Remember, the things we're looking for has to go at the beginning and have to go at the end. Now, I don't know where your teachers taught it. I do this one a little bit differently, mostly because this is the trouble area right here. Trouble area. This is where most of the kids make a mistake. So what I'm going to do is I'm going to get this thing all by itself. I want everything away from it. Gone. Far away as you can get it, okay? That's what we're doing. That's our goal. So the first thing we're going to do is move these two things over, because this is all stuff that's being added, subtracted. So on the left side, I'll have A squared. When I bring that B squared over, it's going to be minus B squared, and then minus C squared. And then I'm just going to copy everything else down. Well, now I still want to isolate this. I still want to isolate that. So I got to get rid of the BC, or the negative 2BC. But this is all connected through multiplication. Multiplication, multiplication, multiplication. So in order to get rid of multiplication, I got to divide by it. Negative 2BC. Gone, gone, gone. But if I divide that side by negative 2BC, I got to get this side by negative 2BC. And now here's the final thing, and people disagree with me on this one. Here's the final thing. Do you see this cosine right here? That's the only thing that hasn't been crossed off. And what I want to do is I want to take that and bring it over here. Well, when cosine switches sides, or when you're looking for an angle, like we're looking for A, we're going to, I always tell my kids, when you bring that cosine over to the other side, it just switches signs just like anything else. So instead of being cosine, it's cosine inverse of A squared minus B squared minus C squared all over negative 2BC. And so since I move this, the only thing left over on this side is A. Well, the cool thing about that is, it's not really cool, it's just nice, is now I'm just going to type in all the numbers. Well, first I'm going to put them in. A is 8, so it's 8 squared, minus B, which is 5. Oh, this is 15, right? 15 squared. Minus C, which is 12 squared, all over negative 2 times 15 times 12. And I just typed that in my calculator. So now I got everything set up. I don't have to think about things. I don't have to move things. I'm just done. I've moved everything. I've done all the work. So now I'm just going to go cosine inverse of this fraction, which I completely have forgotten what's... Let's see if I can do it. 8 squared minus 12 squared. Let's see if I got this right. Minus 15 squared all over negative 2 times 12 times 15. I think I got that right. Maybe the order's a little bit different, but it doesn't matter. As long as the 8 squared's first, I hit enter. 32.0891. So this is A. So A is equal to 32.0891. Rounded to the nearest degree, A is equal to 32 degrees. I did get these right? Oh, yeah. All right, good. That was a tough one. What did you guys do with that one? So this problem is going to be the exact same problem. So you guys can pause this. If you're watching me perform like a monkey, stop, pause it, try it on your own. Because you'll notice it's the same because we've got forces of 9, 11, and they give us the resultant again. And again, then, if we've got all three sides, there's a 999.999% chance. By the way, that doesn't exist. I know that. So don't say, oh, Mr. Krause, did you know that the total percentage that you can achieve is 100%? Anything over that's just ludicrous. I know. Thank you. You're annoying. So, 9, 11, and the resultant is 14. So now what's the question asked? Find to the nearest degree. We'll start highlighting things. Nearest degree, the measure of the angle between the two applied forces of 9 and 11. Oh, this one's tricky. This one's a little tricky. Let me help you through this one because I know you need me to help you. What it's saying is it wants to know what this angle is right here. You are not able to find that angle. It's not possible to find this angle directly. Not possible. What you have to do is find this angle first. You need to find this angle first. And then when you have this angle, what do you know about these two? Okay, Bob. No, that Bob. No, the other Bob. The one's asleep. Yeah, wake up. They add to 180. Great. Nice job. Boy, that guy's smart. He woke up from a nap. They add to 180. You are amazing. They add to 180. Okay, so I know those two angles are going to add up to 180. So how do I find this angle? Well, we're going to call this A and little a. And we're going to call this little b and capital B. And we're going to call this little c and capital C. So we're going to use that same formula. A squared equals B squared minus C squared minus 2BC cosine A. And again, I want to isolate this because I'm looking for this. I want to isolate it. So I'm going to do it a little bit quicker this time. These two are coming over first. So I get A squared minus B squared minus C squared. Once those are gone to the other side, I'm going to divide by this. So divided by negative 2BC. Now this went over, so I divided by it. Now I'm going to move the cosine negative 1 over. So cosine negative 1 of this mess is equal to A. And by the way, on your test, don't start crossing this stuff out on your test. Remember, we need to see your work. And anything that's crossed off, it's like having blinders on. I can't see it. I don't know. I'm like, dude, I know you put something there, but I can't see it. It's gone. Don't know what it is. Oh, okay. So if you scratch it out, we can't look at it. It's as if you erased it really, really well. So now I'm going to plug in my numbers. So cosine negative 1, A is 14. So 14 squared minus 9 squared minus 11 squared all over negative 2 times 9 times 11 is equal to A. And I'm going over to my calculator. Come here, little calculator. Come here, little calculator. Yes, it's late and I'm going a little crazy. But I'm having fun with my friends. You guys are my friends, right? Because I don't really have any friends because I teach math. Do you know what it's like to have friends with a math teacher? I'll bet my big bald head is sitting right about here. And if I write anything over here like I did up here, you're probably not going to be able to see it. And of course, I don't have time to really do these videos amazingly, so I might have my big head in the way. So I'm going to avoid this spot right here because that's probably where my big head is. So I'm going to go over here. So, forgot what I was doing. All right, so it's 14 squared, 9, and 11. So 14 squared minus 9 squared minus 11 squared all over negative 2 times 9 times 11. Enter. 82.263. 82. So A is equal to 82.263. Nearest degree, so that's enough. But that's not what I want for A. Remember, that's A. That's not the question they said. What's the measure of the angle between the two applied forces? So what I'm looking for is this angle over here. So in order to find that, you're going to take 180 and you're going to subtract off this 82.263. Go back to my calculator. 180 minus this answer equals 91.73. So 91.73 rounded to the nearest degree. My final answer is, I'm going to have to write it over here because my big head's in the way, 92 degrees. Yay! Problem 6 done. Hey, look, we only got like a million to go. We're going to be up late. You're going to be here for a while. Fast forward if you get it. Some of these problems are more difficult, so be careful. Ooh, forces. Wait, forces. So, let's see here. What do we have going on? The measure of the angles between the resultant and the two applied forces is 65 and 42. That sounds familiar. I didn't do that already, did I? Oh, no, it's 25 and 38. Okay. So the measure of the the resultant and the two applied forces. So let me get that resultant in there. It's not bad. 42. I'm going to put the smaller one down here and 65 here. Those add up to 107. That makes this then 73. I hope. And if this is 65, this is also 65. Let's see, 65. 60 and 40 is 100. 107 plus 3 is 110. Yeah, I'm good. Yay. Okay. Find if the magnitude of the resultant is 24 pounds. We were given that. Find to the nearest pound the magnitude of the smaller force. So in this case, I'm looking for the smaller force, so I'm going to put an X here. Actually, we don't like X's. We're going to use A and B. So I'm looking for this. I'm going to make this A, so that makes this capital A. We'll make this capital B, and we'll make this little b. So what do I have here? I have 3 angles and a side. You need 2 sides in order to use law of cosine. So in this case, we're going to use the law of sines. Got it? All right, so it's going to be A over angle A. So A is little a. We don't know what it is. All over the sine of 42. I still have kids that'll put A over 42. Hello, it's the law of sines. You got to use sines. Seriously? Let's go, kids. Is equal to 24 over the sine of 73. Oh, where did I get the 73 from? Don't forget, kids, these things right here have to add to 180. All right, let's cross multiply. A times sine 32 is equal to 24 times sine 42. Divide by sine 32. Hopefully my big head's not getting in the way. Ka-ching, ka-ching. Oops, divide by sine 24. Oh. Okay. So somehow brain's not functioning properly. Let's try this the right way. So A times sine 73. 24 times sine 42. And this is 73. And this is 73. Boy, I got my head up my keister. Woo! So A is equal to, and I got to type this stuff in, sine 24, 42. So control division, 24 times the sine of 42 all over the sine of 73. And we get 16.7929. So 16.7929 rounded to the nearest pound. So my answer is little a equals 17 pounds. 2 forces. How many are getting sick of drawing these parallel? Whoa, pen, don't start. I hate this pen. Oh, there we go. Okay. That's awful. I think sometimes my computer just starts to think about other things because it's kind of slow and I really could use a new one. Like a desktop, a really powerful desktop. But of course, I teach math. No, don't make tons of money. I do well. Nobody complains. So we have a 34-pound force. There's the small one. And a 40-pound force. There's the big one. And so the measure of the angle between the 34-pound force and the 45-pound force is 60 degrees. Did I do this one already? Because if I'm doing like multiple duplicates, it just sounds familiar. Sounds like the first problem we did. I just clicked on it. Oh. I can't wait to get off forces. How about you guys? There is a couple difficult ones I think is coming up. So this is 120, right? And I'm sure they're going to ask about the resultant. Oh, man. How many of you are going, Mr. Krause, you're pretty good at math, but maybe reading wasn't your strength? Yo, man, cut me some slack. Have I told you I was old? Okay, so here's the resultant. So let's read this carefully. The measure of the angle between the 34-pound force and 40-pound resultant. So the resultant is 40 pounds, and we'll put the 34-pound force down here. I don't know which one's going to be bigger. The measure between the resultant and the 34-pound force is 60 degrees. 60 degrees. Find to the nearest pound the magnitude of the other force. So they changed problems on us. I remember putting this one in here because it was a weird one. So good. I'm glad. Star it. Make sure you guys do that one. Sorry, kids. Hacking up along. I guess this is what it feels like to smoke, but I don't smoke. All right. So we want to find the other force. So we're really looking for little a. So let's see what we have. Side, angle, side. Side, angle, side is law of cosines. And that's good news because when you're looking for a side with law of cosines, whoo, man, it's really easy. Really easy. All you got to do is write it down. So it's a squared is equal to b squared plus c squared minus 2bc cosine a. That's the formula. So this is a squared. We don't know what that is. And I don't know where my pen went. I'm just going to, oh, there we go. So I get a squared equals, and then b squared and c squared are just these other two sides. So 40 squared, it doesn't matter what order you put them in here, 34 squared minus 2 times 40 times 34 times the cosine of 60. Again, I think I've already said this once. I'm going to say it again. Don't try to do this piecemeal. Type the whole thing in at one time on your calculator. Graders love that, I think. I like it. So I think it was 40 squared plus 34 squared minus 2 times 34 times 40 times the cosine of 60. Hit enter. Hopefully I didn't type anything in wrong. I get, 1396. That's right, because cosine of 60 is a half. So 1396. Doesn't make sense. So what we're going to do is remember to take the square root of that. So the square root of that is 37, 36, 30. 37, 36, 30, rounded to the nearest pound. So I get A equals 37. All right. Oh, man. What is going on? What is this thing? See, I need a new computer because Dell's telling me I have to do something. And I'm going to tell them to get off my computer. All right. So we're moving. Oh, look at that. It's another forces question. Oh, my God. I'm so excited. I still can't find my pen. Okay, so we draw another parallelogram. We're almost done with these kids. Let's see. Now I'll try to read correctly. When forces of 20 pounds and 25 pounds, 20 pounds and the longer one is 25, act on a body, the magnitude resultant is 30 pounds. Now, how many of you right now are going, oh, 3 sides? Law of cosines. You don't have to snap your fingers. It's kind of annoying. And they told me that this is 30. So now I just want to be careful. I know I'm going to round to the nearest degree, highlight everything that's cool, and I want to find the angle between the resultant and the smaller force. So here's the resultant, and here's the smaller force. So I would like to find this angle. So I'm going to call this capital A, and I'll call this little a, and this will be B, and capital B, and this will see C, and capital C. So I have side, and we just said a couple of minutes ago we're going to use the law of cosines. The law of cosines is not fun when you're looking for an angle, but we've done this a number of times, so let's do it. So what we're looking for is capital A. So we're going to start with little a. A squared is equal to B squared plus A squared minus 2 times B times C times the cosine of A. Remember, this is the thing we're going to isolate. So we're going to move these two things over first. So A squared minus B squared minus C squared. Then I'm going to divide by this. divided by negative 2BC. So this got moved over, this got moved over, and this got moved over. And don't forget now, we're going to bring the cosine over. And when the cosine comes over, it comes over as cosine negative 1. Inverse cosine. And now we have isolated A. Now the beauty of doing this, if you can get comfortable with this, is that you can just type all of this stuff right here into your calculator once you get the numbers in. So cosine of negative 1 of A squared, 25 squared minus 30 squared minus 20 squared, all over negative 2 times 30 times 20. All right, go over to my calculator. Hello, calculator. How many of y'all have this nice calculator? It's a nice calculator. It's pretty good. You might want to, I wouldn't go out and get one now because you're not used to using it. Hopefully at some point you'll probably get one. So it was 25 squared minus, don't have a clue, 30 and 20. So 30 squared minus 20 squared all over negative 2 times 20 times 30. And you get 57.771133. So 55771133. That is really weird. So A equals 57. See, I'm so old. 55, 77, 11. 77, 11. I know that's enough because I only want to round to the nearest degree. So A equals 56 degrees. Another forces question. Okay, I think there's only one left. No, two left. There's two left. All right. Find to the nearest degree the angle between the two applied forces of 8 and 10 pounds. Come on, I did this one already. Sometimes I repeat problems or I cut and paste too much. Oh, it was 8 and 12 pounds. See, I was hoping. All right, so 8 and 10 pounds. So this is the little one. This is the bigger one. And if the resultant is 5 pounds, all right, well, my drawing's not very good, but that's okay. The result, this is 5. Oh, yes, great. I have side, side, side again. So you know we're doing the law of cosines, which is a little bit more comfortable or complicated. So we want to find the measure of the angle between the two applied forces. So we're looking for this angle. And I told you a little while ago, you can't find that angle. You have to find this angle right here. This is the angle you have to find. So we're going to call that A, capital A. And this is little a. And then we'll just call this B and capital B and C and capital C. So again, we're going to do A squared equals B squared plus C squared minus 2BC cosine A. We're going to isolate the A, so we're going to move this stuff over first. So it's A squared minus B squared minus C squared. You got to always take care of the adding and subtracting first. So I got rid of that. Then I'm going to divide. Then I'm going to divide by this negative 2BC. And I'm then going to move the cosine over. So it makes it cosine negative 1 of this conglomerated mess is just equal to A. So cosine of negative 1 of, what's A? 5 squared minus 8 squared minus 10 squared all over negative 2 times 8 times 10. Go to my 5, 8, 10. So inverse cosine. Got to get a fraction. 5 squared minus 8 squared minus 10 squared all over negative 2 times 8 times 10. Enter 29.686. 29686. 29686. All right, I had to do that before I forgot. So A is equal to that, but that's this angle right here. Remember? That's this angle. We don't want this angle. No, we don't want it. We want that angle. right here. And it says, remember that these have to add to 180. So I'm just going to take that and I'm going to subtract 180 and subtract that angle. Minus that. And I get 150.3137. 151. So the answer, not A, but the answer is 150.317, round to the nearest degree. I don't know why I had these all round to the nearest degree. That's way too easy. There it is, 150. Last forces question. Jay and Bernie are pushing a box. Jay pushes with a force of 50 pounds in an easterly direction. By the way, this is easterly direction of 50 pounds. And Bernie pushes with a force of 49 pounds in a northeasterly direction. This would be northeasterly direction, and he pushes with a 39 degrees. How many are looking at those exponential problems below going, I want to do those. Let's finish this last problem. The resultant force forms an angle of 32 degrees with... So let's draw on that resultant force if, in fact, I can find my pen. And that was a little advertisement for OneNote. There's 39. So it says, the resultant force forms an angle of 32 degrees with the 39 degree force. That's it. Find the angle between the 50-pound force the resultant force forms an angle of 32 degrees with the 39-pound force. Oh, so then the question says, find the degrees between the 50-pound force and the 30. So I want to find this whole thing. That's quite interesting. All right, so this is also 32. Let's get stuff going. That's 32. So I'm looking for this. I don't think I have enough information for this. I have angle side side. Oh, yeah, I have angle side side. Oh, this is a tough question. So what I want to do, what I really need to do is find this. It says find the angle between the 50-pound force and the 39-pound force to the nearest tenth of a degree. Well, I'm going to find... Wow. Okay, so what I have to do is law of sine. So what I'm going to do is 50 over 32 is equal to, and I'm going to call this y or something, y over 39, because I really want to find this angle. So y over the... Sorry, kids. Screwed that up myself. 39 over the sine of y is equal to 50 over the sine of 32. And if I don't write any smaller, I'm never going to get this in here. So I'm going to cross multiply. So I'm going to write small. 50 sine y is equal to 39 times sine 32. And then we're going to divide by 50. Divide by 50. So this becomes a tough question. So I've got sine of y is equal to 39 times sine 32 over 50. But I need to get this y by itself. So I got to move this sine over here. And when I do that, it becomes sine negative 1 of this mess. So 39, 32 over 50. So inverse sine, fraction, 39 sine 32 over 50. That was what I had on the other side. I hit enter. So I'm not going to round now. Wait, unless it tells me to round. What was it? 24,414. So y is equal to 24.414. All right. So Find the... So it wants this... It first wants this angle. Well, in order to get that angle, I found y. It's 24. So this is 24. So part A of this problem is 32 plus 24.414. So this angle A here, I guess, for part A, is equal to 56.414, or angle A is equal to 56. Oh, I'm not done yet? Oh my gosh. So now it says it wants to find the magnitude of the resultant force. Well, I'm going to use this 56 now. Because if that's 56, then this has to be 124. Because they have to add up this plus this. Have to add up to 180 degrees. So now, I'm going to erase, kids, just so you can see, because I know it's a mess. So now I want to find this. I will call this little a, and let's call that little a, and let's call this capital A. So in this case, I want to find this. So I'm going to do law of sines again. A over sine A. So little a, we won't call this A. Call this A. Little a over the sine of 124 is equal to, again, 50 over the sine of 32. And I'm going to fast go through this. A times sine 32 is equal to 50 times sine of 124 divided by sine 32 divided by sine 32, and I get A equals this mess right here. So 50, 124, 32. I won't remember that. 50 sine 124 over 32. Hopefully that was right. That doesn't make any sense. It's not 32, it's the sine of 32, isn't it? Let me just make sure. Yeah, sine of 32. That was kind of dumb. Sine of 32. $78.22. That should be enough. 78.22, so this one equals 78.22. Rounded to the nearest pound, the answer is 78 pounds. All right, I'm going to stop there and then come back because my pen's getting crazy. So, okay, for you that was no time at all. For me it was like 2 minutes. Just had to kind of cash out of that thing. Sometimes I think it just beats up my memory. Okay, so I want to try these problems. First thing I'm going to do is erase a little bit, give myself a little bit of room from the last stuff. Okay, so in order to solve these problems, what we want to do is we want to make the base the same. Now, this is an exponent. This is a fraction. If you remember correctly, if I have x to the negative 1, that's equal to 1 over x. If I have x to the negative 2, that's equal to 1 over x squared. So having said that then, if I give you 1 over x cubed, could I write that as x to the negative 3? I sure can. Well, that's how we do these problems, believe it or not. This is 6 to the x plus 1. Now this is really 1 over 6 squared. Notice I'm looking for that same base. And that's equal to 6 to the negative 2. Great. Now that I have the bases the same, all I have to do is set the exponents equal to each other. So I get x plus 1 is equal to negative 2, or x equals negative 3. That's it. I can check it, but I'm not going to because I don't have time. It would work. So over here, I've got 8 x to the 8 to the x plus 2 is equal to, now this thing in here is really 8 to the negative 2, because this is really 1 over 8 squared, but that becomes 8 to the negative 2, all raised to the x power. Now, if you remember correctly, when we have exponents raised to exponents, we multiply those exponents. So, now that I have 8 to the x plus 2 and 8 to the 2x, or negative 2x, excuse me, I just set those exponents equal to each other. So I get x plus 2 equals 8. What am I doing? Not 8. Just set the exponents equal to each other. Equals negative 2x. So I'll bring this over, negative x, minus x, and I get 2 is equal to negative 3x, divide by negative 3, divide by negative 3, and I get x equals negative 2 over 3. Ooh, this one's a little bit tougher. You got to know that 81 is really 3 to the 4th. So 1 over 81 is really 3 to the negative 4. So 3 to the x is equal to 3 to the negative 4. Oh, so x equals negative 4. How many want to go back to those forces questions? These are so easy. 27 is really 3 cubed. So when I got this 1 over 27, that's really 3 to the negative 3 to the 4th power equals, well, I'm going to write it as equals 9 to the 2x. So what I have over here is 3 to the negative 12 is equal to, now in order for this to work, the bases have to be the same. So I can't use 9, that's why I hesitated for a second there. I can't use 9. I have to replace this 9 with something that it is, but it has to be a 3. So 3 squared times 2x. So this becomes 3 to the 4x. Because 3 squared is 9. So it's 3 squared to the 2x. All right, so now that the bases are the same, all I have to do is make sure that the exponents are the same. So 4x equals negative 12, so x must equal negative 3. I did not write this problem correctly. Well, all right, well, okay. The bases are the same, so I'm going to get 3x equals x plus 1, so 2x equals 1, or x equals 1/2. That'll never be on a test. It's too easy. I somehow miswrote that question, so we'll skip that. 25 is 5 to the negative 2 is equal to 125. Do you know that 125 is 5 cubed to the x? So now that I have that, I'm going to set these exponents equal to each other. 3x equals negative 2, or x equals negative 2 over 3. Almost done, kids. 7 to the x is equal to 7 squared to the 8th power. So exponents raised to exponents, we multiply those, so we get x equals 16. Kind of boring. Why, oh why? I don't really like this thing. I might have to change this a little bit. Can't do this one, because I can't make 72 into a 5. I'm not saying the problem can't be done. I'm just saying you can't do it this way. So what we have to do in this case is anytime the exponent is a variable and you can't solve it one of the ways we just did, you have to use logarithms. So what we're going to do is we're going to log the left side. So log of 5 to the x. But if you remember correctly, exponents come first. They come out front, is equal to log of 72. So to solve for x, I just divide by log of 5. Divide by log of 5, and I get x equals, now you guys know my secrets. I use Camtasia Studio to make my videos. Log of 72 over log of, was it 5? I believe it was 5. 2.657. So it should have said right around 2.657. That's good enough for now. All right. Now we're going to do some word problems with logs, and then we're going to be done. Yay! I only think I got 1, 2, 3. Oh no, shoot. Then we got some graphing stuff. I like that stuff, but it's going to be time consuming. So let's try to get through this stuff as quickly as possible, but so that you can understand it. So here's our equation. C equals this, where C is the final number of bacteria. So C is the final number of bacteria. C is the final. I is the initial. I should have made that a capital. T is the time in hours. It says the initial was 7, and we want to end with 3,200. So in for the final amount goes 3,200. In for the initial amount goes 7. And we're going to just copy everything pretty much else down. 2.4 to the 0.621 T. All right. In order to solve these types of equations, you have to isolate the weird thing. And in this case, the weird thing is this base to this exponent. I want to get this thing in green all by itself. So what can you tell has to go? Good, the 7. So we're going to divide both sides by 7. So divide this side by 7 and divide this side by 7. And I'm just going to leave it as 32 over, maybe not. Go over here to my calculator. I'm going to do 3,200 divided by 7. I don't think I was nice. Of course. Oops. Try this again. All right. Enter. Decimal point. Boom. 457.142. So 457.142. Do not round early. 257. 142. 857. 857. 143. Don't round early is equal to, especially when you're working with decimals like this, 2.4 to the 0.621 T. Whenever the variable is an exponent, the only way you're going to be able to solve this is using logarithm. So what we're going to do is we're going to log the left side. So log of 457.142857143 is equal to. Now, when we log this side, it's the log of 2.4 raised to this exponent. Well, if you remember correctly, exponents come in front of the word log, so it's 0.621 T. Now, I need to get this T all by itself. So everything that's around it has to go. So we're going to divide both sides by 0.621 log 2.4. So I'm going to divide that side and this side. 0.621 times log of 2.4. So this goes and this goes. So now I'm going to come back over here. I'm going to log this. Log of, please go in the right place. Enter. Oops. So control division log of this divided by 0.621 times the log of 2.4. And I hit enter and I get 11.266. So my answer is, not sure why I don't have a thing. So my answer is T equals 11.266, rounded to the nearest tenth of an hour. So T equals 11.3 hours. Done. Let's do another two more. So we're going to use this formula. Careful with this. We'll talk about that in a second. So C is the original cost. T is the number of years. R is the rate. And if the boat costs $40,000 new. So that's C. That's the cost of the boat. So we want to know what the value is of a $40,000 boat. 1 minus. Now this rate is 8%, but as a decimal is 0.08. So minus 0.08 raised to the t. Oh, and we want to know when the boat's going to cost us is going to be worth $18,000. So I'm going to get rid of V because my final value I want it to be is $18,000. So we're going to isolate the weird thing. In this case, the weird thing is this. We're going to get this all by itself. Remember, eventually we're going to get that t by itself. So we're going to divide by 40,000. So 18,000 divided by 40,000. 18, 1, 2, 3, decimal divided by, if I don't put the decimal in, it'll give me 40,000 is 0.45. So 0.45 equals 1 minus 0.08 is 0.92 to the t. Well, in order to get this out of being in an exponent, I have to use logs. I know you hate them, but you have to. So log of 0.45 is equal to t times the log of 0.92. Remember, this would be 0.92 to the t, but the t comes down front, so we don't have it here anymore. Divide by log 0.92, and I'm done. Well, except for maybe a little rounding. Log 0.92. 9.992. So 45 divided by 92. So control division, control log of 45 divided by control log 0.92. 0.92. Oh, it wasn't 45. It was 0.45. That wasn't very smart. 0.45. 9.576. 9.576. So T equals 9.576. 576. Round to the nearest tenth of a year. T equals 9.6. That's it. One more. Colony of cells. So I'm just going to go through this quickly. You can pause it if you want to. We want 25 cells to become 25,000. So 10 times. So 25,000 is our ending amount. Our initial amount is 25. That's I. 3.1 is my growth factor. And this is 0.226 T. We got to isolate the weird thing. So we're going to divide by 25. 25,000 divided by 25, that's pretty simple. That's just 1,000, is equal to 3.1 to the 0.226 T. I have to isolate the weird thing. I did that. Now, in order to solve it, I have to use logarithms. I'm going to log the left side, log of 1,000. By the way, if you do know that, that's 3. But if you don't know that, don't worry about it. Is equal to 0.226 T, because exponents come first, log of 3.1. I still need to get T all by itself, so I'm going to divide by 0.226 log 3.1 and divide this side by 0.2, what is that? 0.226 log of 3.1. Gone, 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 gone. So T is equal to log of 1,000 divided by let's see if I can get this in right. Control division, control log. By the way, I don't have to put the 10 down there. It's understood to be there, 1,000. All over 0.226 times the log of 3.1. 3.1. Enter. 27.015. 27.015 to the nearest whole hour. 27 hours. All right, I've only done 3. If you'd like to see more, if you want something else, email me. Let me know. Wow, that was cool. Change of clothes and everything. Wow, that's amazing. Actually, it's the next day. Because what happened was, I put some problems in here that didn't work. So I went to bed because I was tired. And then I got up. And now I'm going to do these problems for you. I had to fix them. So here we go. We're going to graph and solve 4 systems of equations. Shouldn't take that long. It's pretty simple. But you got to know what you're doing. All right, let's do this. This right here is... Hopefully you all recognize that this is a line because it's just got a y, it's got a plain x. It's got a slope of 1 and a y-intercept of 0, 5. So we'll go to 0, 5. 1, 2, 3, 4, 5. And we're going to go up 1 to right 1. Graphing line should be easy. If you want to put a table of values on, put a table of values on. That's a cool thing to do too. And we will draw that almost straight line. You will have a straight edge on the final because you will. This is a circle with a center at 0, 0. Don't worry, I'm going to do one without a center at 0, 0 later. And a radius, if you recall, the radius is equal to the square root of this, which is just 5. So we're going to go with the origin. Centered at the origin. I'm going to go up 5. Oops, I'm going to do this in different color. Let's go green. Origin, up 5. Left 5. Wow, I know our answers already. Right, down 5 and right 5. I hope I went 5. So, come on. There it is. All right, and so my 2 answers, don't forget, whenever you solve systems, you have to have answers that are points. Maybe you couldn't hear me as well because now I got the mic next to me. They're going to be points 0, 5, and -5, 0. That's it. So that's the algebraic way. Now let me delete this so you can see that's the graphical way. Now let me show you the algebraic way. So this, if you recall, is y. So what I can do with this is take this and plug it in for the y that I see there. It's called the substitution method. So instead of x squared plus y squared equals 25, we're going to plug in this in for y, and we get x plus 5 here. Notice now we're only working in one variable, and that's what you want to be doing, because working in 2 variables kind of sucks. So x squared plus. Now, if you're a smart kid, you're going to double distribute it. If you're not too smart, you can do something silly. Don't forget this is x plus 5 times x plus 5. So that becomes x squared plus 10x plus 25 is equal to 25. So I bring this 25 over by subtracting it. These are going to go away. And then I clean up the left side. I get 2x squared plus 10x equals 0. Factor out a GCF of 2x. I get x plus 5 equals 0. Or my 2x solutions are x equals 0 and x equals -5. But you still have to go find the y values. So I'm going to take this simple equation down here. I'm going to write y equals x plus 5. Clearly, when I sub in this 0, I get y equals 5, giving my first answer of x0, y5. Well, look at that. Matches that one. And then I'm going to plug in -5 into this equation again. This time it's going in. -5 is going in, and I get y equals 0, giving me the point -5, 0, which matches this point. Now, I forgot to start my calculator. Not sure I'm going to need it, but we'll see. I think maybe I might. So that's coming along. That should be up in a minute. Probably annoying me. It is annoying me already. All right, so while that goes, we're going to graph this thing first. This thing is a line. It says 2y equals negative 4x minus 10. By bringing that over, I'm going to divide everything by 2. And I get y equals negative 2x minus 5. These better work. I found these on a different thing. My other ones didn't work. You don't know that because I'm erasing the evidence of my mistakes. So down to right 1. Down to right 1. And then we'll turn that around and go the other way. And I will do my very best to try to hit at least most of those points, which is very difficult to do. It was bothering me. All right, so that's done. Now I got to do this parabola. Let's change color. The parabola. Oops. Yes, the parabola. So, let's see. First thing I'm going to do is the axis of symmetry. X equals negative b over 2a, which is negative 16 over 2 times 1, which is negative 8. So negative 8. Oh, yeah. Let me fix that. That was embarrassing. Pretend I didn't see that. So x equals negative b over 2a. So this is negative 16 over 2 times 2, which is negative 4. So negative 4 is going to be in my table of values when I type this into my calculator. Negative 4 should be somewhere in the middle. Graph this puppy. So it was 2x squared plus 16x. No idea. Plus 23. Plus 23. I guess that's what it is. It is what it is what it is. Okay. Just out of curiosity, I'm going to graph the other thing. What was that again? Negative 2x minus 5. Negative 2x minus 5. Looks like there's my points of intersection right there. Right there. And somewhere up there somewhere. Nice point right there. Hopefully it works out. Anyway, I want to go to the table. Control T. And I'm only going to look at the blue equation. So, I guess I don't want to get to 1. One's a little bit too big. So, negative 7, 9. So, negative 7 will be the first one. Negative 7, negative 6, negative 5. Negative 7, 9, 6, 0. Nope, 6, negative 1. Negative 5, negative 7, negative 9. This would be negative 3, negative 7, negative 2, negative 1, and negative 1 would be 9. Let me just verify. I'm sure I'm right. There it is. Negative 1 is 9. Okay. So negative 1, 9. Negative 2, negative 1. Negative 3, negative 7. Negative 9. And 9. So this looks like it hits. And the 2 points of intersection would be... By the way, this would not fly on the Regents exam. You have to hit the points and you have to make it look like a sharp curve. It's hard to do with this thing. So here are my 2 points of intersection. Right here, my 2 points of intersection are negative 2, negative 1, and negative 7, 9. All right, we did it algebraic. We did it graphically. Keep screwing that up. Now, I need some more room. By the way, if I was doing this, I don't know, probably do a little bit differently. Probably should give you more room, but I kill more trees that way. All right, so let's do this algebraically now. I think I solved this and got y equals negative 2x minus 5, correct? So what I'm going to do with this, since this is y, is I'm going to plug it in for that y. They're equal. They're the same thing. They're just y values. I want to make sure those y values equal. So I'm going to say negative 2x plus 5 has to equal 2x squared plus 16x plus 23. Set this equal to 0. I get 2x squared plus 18x plus 18. Looks like I got a GCF of 2, so I'll take that out to make my factoring easier. X squared plus 9x plus 9. Something's not right. Oh. Alright, so here's where I made my mistake. You see this right here? This is where you make common mistakes. I knew it was something wrong right because this worked out nicely. And this didn't. So notice I made my mistake here. How many of y'all saw that when I was... By the way, on the Regents exam, this is not a minus sign. You know what that is? That's a mistake. Because if the teacher can't decide what it is, it's wrong. So don't be stupid. Erase. Yeah, or if he says you have to work in pen, rewrite. That's a minus. When I bring it over, I'm going to add it now. So I get 28. And when I take out 2, I get 14. Much better. X plus 7. X plus 2. Multiply to 14, add up to 9. So my two answers are x equals negative 7 and x equals negative 2. Now, if you're just solving this algebraically and you haven't done it graphically, don't forget, you still need to find the y values. I found the x values, but you still need to find the y values. So I'll take that equation, y equals negative 2x minus 5. Plug this in. So I get y equals negative 2 times negative 7 minus 5. So that's 14 minus 5, which is 9. Then I'm going to do y equals negative 2 times negative 2 minus 5 by plugging that in. And I get y equals 4 minus 5, which is negative 1. So my two answers then are, in fact, these two right here. Whoa. Oh, yeah. Negative 7, 9. So this one gives me negative 7, 9, and negative 2, negative 1. Ooh, had a brain fart there for a second, kids. Sorry. All right, 2 left. So we'll graph this easy one first. Y equals negative x plus 1. So it's got a y-intercept of 1, and it's got a slope of negative 1, so it's coming downhill. It's hitting all the corners coming downhill. That shouldn't be an issue. If you need to do a table of values, do a table of values. You know, why else? Why not? The other equation, if you're looking at it, which most of you aren't because you're either frantically watching me copy or you are doing this on your own, I hope. But the other equation is a circle. So this one, which we will do in blue, is a circle with a center. And you always got to give a little bit of information. The center is going to be positive. Should be positive for negative 1, but that's not the way I set this equation up. I know that's not the way I set this equation up. So I had a little brain fart. So what I'm going to do is I'm going to switch this equation around. And when you see it, if you see it on the table, you'll see it. This will be an x. If you have the document, this will be a plus, and this will already be a minus. Because this is, I know the way I set the equation up. So this should be negative 4 and positive 1. Remember, when you take the center out, so this equation will be x plus 4 squared plus y minus 1 squared equals 16. And don't forget, when you take the center out, they come out with opposite signs. So in this case, my center of my circle will be negative 4, positive 1. It will have a radius of 4. And you'll see that this will work. Because before it didn't. 1, 2, 3, 4. It was trying not to work again. So we're going to go up 4. 1, 2, 3, 4. Right 4. down 4, and left 4. And we'll draw our circle in, try to make it look somewhat like a circle, not like a diamond, although this is pretty rough. I'm actually really good at this if I'm on paper. So my 2 points of intersection are 0, 1, and -4, +5. So those are my 2 answers. So let's try to do this algebraically now. This is y. So I'm going to plug this in for y. So what I'm going to get is x plus 4 squared plus -x plus 1 minus 1 squared equals 16. So because this was this thing I plugged in, and then it also had the -1 right here. So this, if I double distribute, don't do anything stupid, you got to double distribute x squared plus 8x plus 16 plus, these cancel. So I just end up with x squared equals 16. Or 2x squared plus 8x. Now when I bring the 16 over, these are going to cancel again. Very difficult to write a circle question when they don't match nicely. So that's that. Take out a 2x, and I get x plus 4 equals 0. So my 2x values are x equals 0 and x equals -4. That kind of matches what I got before. I still got to find the y value, so I'll write down y equals -x plus 1. If I plug in 0, that's just nothing. I get y equals 1. So this point is 0, 1. That matches. And then y equals -x plus 1 here. If I type in a negative, now you got to be careful here. Y equals -4 plus 1. I almost forgot the negative. -4 is just positive, so y equals 5. And that point is -4, 5. And that matches as well as the other one. All right. Well, we got 2 left, 1 left. Last problem. Sweet. Uh-oh. Got a funky one. All right, that's a lot of space here. So I'm going to do the equation of the line. The equation of the line is y equals x minus 6. I haven't checked this one. It better work. Although I thought I checked the other one too, and it didn't work. So there's -6. And it's x plus. So we're going to go up, 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 up and away. By the way, if you like what you see, you can subscribe to my YouTube channel. You might want to hit that like button a few times. Just hit it once, because if you like it and then unlike it and then like it and unlike it, they're going to think you got like multiple personality disorder. And then I'm going to be like, okay, Mr. Krause is only teaching the crazies. Which, if you've seen my classes, Ellie, yeah, you know, you've seen them come from crazy kids. Nah, I'm just kidding. I got great kids. Great kids. Otherwise, I wouldn't be doing all this work. And I appreciate all the emails you guys have been sending me. Those are awesome. I'm glad I'm helping some of you guys help pass this test. I hope it works for you. All right, let me get back to math. First, we're going to do the axis of symmetry. I get x equals -b over 2a. So that's +4 over 2 times 1/2. And this is just 4 over 1, which is just 4. So I know that in the center of my table, x and y, I'm going to have a 4. So this will be 3, 2, probably 1, and then this will be 5, 6, and 7. Go to my graph. Don't save anybody else's crap, even my own crap. Go back in, and we're going to graph this parabola, which is 1/2 x squared minus 4x plus 6. There it is. Crazy looking thing. We'll go into table. So what do I got here? -1, well, 0, 6. I didn't even get to 0. Shoot, that was dumb. All All right, so 0, 6, 1. I'm gonna do this 1, 2.5, 2, 0, 3, negative 1.5, 4, negative 2, 5, negative 1.5, 6, 0, 7, 2.5, 8, 6. All right, I should have done this in a different color, but alas, I did not. We're going to do it in red, though. So 0, 6, 1, 2.5, 1, 2.5, 2, 0, 3, negative 1.5, 4, negative 2, 8, 6. So my parabola is going to look like this. I remember writing this question. All right, great. Woohoo! There's an answer and there's an answer. It looks like my two answers are going to be 4, negative 2, and 6, zip. All right, let's do this algebraically. Don't you wish you could do that? It's awesome. All right, so y is equal to x minus 6. We already know this. So we're going to take this, sub it in for y. So I get x minus 6 equals 1/2. Oh, guys, there's a half in the problem. What am I? What? I can't even. I can't even screw around. Sorry, kids. Just cough that lung up. Let me put that back in. All right, guys. Seriously, don't whine about the fact that there's a 1/2. The way you get rid of a 1/2 is you just go through and you multiply everything through by 2. You're basically multiplying both sides by 2. So you get 2x minus 12 equals x squared minus 8x plus 12. That's a beautiful, beautiful method. Beautiful. I'm not gonna lie, it's beautiful to get rid of fractions because we hate fractions. Fractions makes us cry. Make us cry. Everything's coming to the right side. So we get x squared minus 10x plus 24. We're going to factor this. I believe it's going to be x minus 4, x minus 6, 0. And then I get 0, oh no, wait, hold on, I'm done. X equals 4 and x equals 6. Is that what I got before? Ooh, yeah, but I still got to figure out what the y values are. So I'm going to type this in. I'm going to write this in. Y equals x minus 6. So I'm going to type that, put that in there. So I get 4 minus 6, which is negative 2. So my first answer doing it algebraically is 4, negative 2. Matches. I'm going to do y equals x minus 6. Plug this in. I get y equals 6 minus 6. Y equals 0. Matches. 6, 0. All right, that's it. That's all she wrote. I got the graphing done. Fantastic. Wonderful. Love it. All right, kids, if you like it, subscribe. Hit the like button once. Don't hit the dislike button. If you got a comment, give me a comment. Want to send me an email, send me an email. If you get 100 on the Regents exam and you use my materials and you love it, send me an email. Let me know who you are, what school you go to, what grade you're in. You know, what's your favorite sport? It's got to be soccer because that's my favorite sport. All right, good luck on the Regents. Keep working hard. Peace out, kids. All right, peace out. Okay, now I found it. Bye.